Now we'll start today's third session. Good afternoon, one and all present here. On behalf of Department of Mechanical Engineering, Christian College of Engineering and Technology, Bhilai, I, Dr. R.H. Gajgat, welcome you all in today's afternoon session of 1 week faculty development program of 3D printing and design organized by Department of Mechanical Engineering, Christian College of Engineering and Technology, Bhilai, sponsored and funded by AICT under AICT Training and Learning Scheme. Today's invited speaker for this session is Dr. Abhay Kumar M. Kuthe from VNIT Nagpur, who has already joined with us. You are most welcome, sir.
Thank you. Thank you.
It's our honor and privilege to have Dr. Abhay Kumar M. Kuthe with us, who will deliver a talk on 3D printing in innovative medical devices. Now I would like to give a brief introduction of our today's speaker, Dr. Abhay Kumar Kuthe. Dr. Abhay Kumar Madhusudan Kuthe is presently working as a professor, higher administrative grade in Mechanical Engineering Department at Visvesvaraya National Institute of Technology, Nagpur, Maharashtra. He began his career in 1986 after completing Bachelor of Engineering Mechanical from Government Engineering College, Amravati, India, by joining Hindustan Aeronautics Limited, HAL, Nasik. He obtained his MTech from IIT Roorkee and joined Birla Consultancy Services, BICS, as Senior Software Engineer. He left BICS and joined VNIT in 1993. He earned his PhD in 2001. His research work is focused in the area of rapid prototyping, using computer-aided design as base and specialized techniques of RP. He dedicated his efforts in harnessing this technology for practical use. The capabilities of RP equipment were extensively exploited to make custom-built metallic implants that were implanted in human bodies by surgeons in several complicated medical cases, including some cases of cancer. The technology was also effectively used in engineering industry to develop zero-defect pattern making and casting. He has earned 2 patents for unique work undertaken by him. His contribution to international and national journals, presentation of papers at international conferences, and authoring the book demonstrate his deep study as well as authority on the subject. Creation of well-equipped CAD/CAM center at VNIT speaks volume of his passion for raising the bar of academic standard. His self-motivation for introduction of industry-oriented courses, guidance of PhD and MTech students, as well as untiring efforts in creating awarenesses and building capacity for large-scale adoption of RP using CAD is a testimony of his work in his area. The all-encompassing contribution of his in the area of RP expands the several conventional boundaries of research. We are fortunate to have such an eminent personality with us. Thank you very much, sir, for joining with us.
Yeah.
Now I would request to you to start your session, sir. Word to you.
Yeah. So thank you, Professor Gargat, Radhesham Gargat. It's really nice to rather join as a speaker in your online FDP, 3D printing and design. And it's interesting that you people are very active in rather conducting such type of the FDP. And I'm also fortunate that I'm invited to deliver the talk on the 3D printing innovative 3D printing and innovative design. I'll be delivering the 2 sessions. So the first session is about the innovative medical devices and another one on the startup perspective. Wish to just share my screen. Let me see if I can share the screen. Okay. Yeah. Yes. So can you see my slide?
Yes, sir. Yeah.
Yeah. Yeah. Nice. So it's great to rather join with the Christian Medical College uh, in this FDP. And the title of my today's talk is 3D printing in innovative medical devices. I hope that everybody is safe and taking care in this pandemic. The two photographs you can see, one is the front gate of our Vishweshwara National Institute of Technology, Nagpur. And second one is the CAD/CAM Center, where we actually work, or rather the research projects, the two research projects, hopefully everyone can see in the background, the two projects which are shown as in the form of a banner there. The one is, we call it as a Biomedical Engineering and Technology Incubation Center called BETIC, and another one is the Smart Foundry. So we work extensively on these two projects. Presently, both of the projects are ongoing. And in this CAD/CAM Center, we do have the facilities, the state-of-the-art machineries like 3D bioplotter, which is the one of the best, one of the instrument where we can actually work in the area of the tissue engineering. We do have the two FDM machines and all the conventional machines which are required for the automation, especially the CNC machine, EDM, ECM, and all. We do have in the induction furnace, and the e-foundry cell under IIT Bombay is active in our CAD/CAM Center. These are the facilities at CAD/CAM Center. It will be quite interesting for me to rather see all of you visiting our CAD/CAM Center and go through the facilities that we do have. And it's also interesting that all these facilities are being used extensively by the research students. And I'm happy that the research work carried out at this CAD/CAM Center is now leading to the deployment of the research in the form of a startup, about which I'll be talking in one of my sessions. The agenda for my today's lecture is introduction, then the points of concern, 3D printing in medical domain, that is what I'm going to talk about. Then the research at VNIT, what exactly we have done in this particular domain of 3D printing in medical domain at VNIT, what research we have carried out. And finally, the conclusion. Now, conclusion is important because I always look at the lecture which I'm delivering in FDP or in any colleges, that there has to be some takeaway message after the lecture. And the participant should always rather think about what they have heard from me, and then they should be properly guided with the certain takeaway message. And that's why I wish to rather look at the conclusion as one of the important agenda in this particular lecture. Let's start with the introduction. And the all of us are very much aware that the manufacturing industry is now customer centric. Customer is very important nowadays. And there are two interesting, rather the parameters, where we actually look at the customer feedback. The first one is the customer satisfaction, and second one is the customer experience. The customer satisfaction, I think all of us are very much aware that we do, many times you have been asked, well, how much you give the rating in a about anything that you have gone through. So even on the online also, once our Zoom meeting is over, immediately there will be a flash saying that how far you are satisfied with the Zoom meeting. And out of the 5, how many stars you would like to give. So that's what we generally call as a customer satisfaction in many products that we do always look at. And we even give the feedback to the manufacturer or the those who have actually designed the product. But the customer experience, I just put a question mark there. What exactly the customer experience means, or rather, how far we should look at the customer experience? Let's look at this interesting slide and what exactly we wish to rather look at the customer experience when it is compared with the customer satisfaction. Now, I'm just giving an example of a car horsepower. All of us are driving cars. So, look at the very first picture where you can see your car being used as a vehicle for you to commute to your office on weekdays. And what you will realize that the horsepower of your car, you don't look at it. You say that, oh, it is comfortable because you can very easily go on a road and reach office very smoothly. But if you look at the same car as a vehicle for your outing on the weekends, so you know that whenever you take the car somewhere on a hilly road or on a ghats and all that, sometimes you feel that yes, I should have the more horsepower in my car, and that would have you might have enjoyed the ride with the car if the car has the more horsepower, but that's only on a weekend. And then again when you use that car on weekdays for going to office, then you are again satisfied with whatever the car horsepower you do have. So you start thinking about, can I just top up the horsepower at the gas station only when I'm going outside the for outing. So that's what exactly is important. That is it possible to change the behavior of the product while it is in use? So the customer experience changes. Weekend, he may be having a different experience of the same product. On weekdays, he is satisfied and his experience is different. So, the product behavior definitely changes when it is being used. So, what exactly we look at the product, that there is always the need of new product, and that's what we always say. It's a very good cartoon that you people must have seen it, that some people are working and the other fellow is just asking, can you use my innovation? But they say, no, we are too busy and we don't rather look at what innovation you are talking about. So everybody is in search of a new product, next product, and that's the interesting thing. We should always look at that whatever the product we do have, we should always think about the new product, some innovation in the existing product, and that's the key of the success as far as the customer satisfaction is concerned. And so customer experience may change, but ultimately the customer satisfaction will be possible if you go on innovating new things in the product. So that's what exactly is very important, and therefore we'll have to think about the innovation in the product every time. Okay. Now let's look about the points of concern. Let's look about this product development or the new product innovation and all that. Now when you look at the manufacturing scenario in India, it's very disturbing to look at the figure or the bar chart I'm showing. And there what you'll find, it is indicating the total patent that are filed in 2017 and total patent that are granted in 2017. The figure hardly changes, the pattern hardly changes, though the figure changes marginally, but the pattern doesn't change much. Because what you look at when you see the patent applications and patent granted, you'll find that the number of applications are definitely more in China, US, Japan, and Europe. But compared to that, when you look at India, the number is very, very small. What exactly it indicates? It indicates that the innovation, to which we generally call it the research, and which is reflected by filing the patent or the grant of the patent, is very much poor as far as the India is concerned. That means more thrust is required in the research so that there will be more and more patent filing, at the same time more and more grant of the patent. Because ultimately, whatever the research you do, whatever the research we claim that it is a research, it will be only accepted if at all we file the patent. So about the patent and other things, I'm definitely going to tell you in the another session. But what is important here is to understand that more thrust is required to get your research patented. And once the research gets patented, then only the your research is deployed. And that deployment is to be seen by either getting that particular patent used in the industry, or maybe you are yourself starting your own company using that particular patent. Now let's look at another point of concern, that we have the stiff competition with manufacture from developed country. Whatever may be the product, if the product is manufactured by the developed country, then we always find more problematic to enter into such domain. Now, I'm just showing another interesting bar chart. It is about the non-oil trade deficit. Most of the time the people say that it is the oil, the more import bill is because of the oil import. But if you look at the product, which we call as a non-oil or non-petroleum product, the figure is very much disturbing. It is rather more than the oil. If you look at the July figure, it is around, it's going in minus 9.6. So, so many billions of dollars is the import bill for non-oil or non-petroleum products. And there we'll have to be more careful about. Let me show you another interesting data related to the medical devices. And, because my lecture is focusing on that, so ultimately it will be of more interest to me to just show you the import bill of the medical devices in year 2014-15, and the same figure in case of the financial year 2018 and 19. The total import in 2014-15, it was around 23,169 crore, and in 18-19, it is 38,837 crore. The latest figure of 19-20, 2021 is not yet published officially, but I'm sure that it is more. What exactly it indicates? That if you talk about the medical devices, then more and more import of the medical devices, that means more and more usage of the medical devices of the imported medical devices indicates that the medical fraternity will start developing more and more confidence in such devices. And now when you actually enter in the medical domain with your own product, which may be an import substitute, you may have to face a lot of problems, because the medical fraternity has already developed that confidence in the imported devices. They have started using it also extensively, and therefore the Indian manufacturer faces a lot of problem, and that's what I already mentioned earlier also, that the competition from the developed country is very, very problematic for the Indian manufacturer. You know, look at the our technology vision 2035 document. It is already available on the net. You can definitely see that. And we are just predicting that what will be the India in 2035. One of the things which I like is that if you look at my cursor, it is indicated there the indigenously manufactured passenger aircraft. That is what is the picture where we are now showing in 2035. That means, you know, most of the aircrafts are manufactured by the Boeing. So on an airport, when you will be actually interested in flying to any city, you know, there are two planes standing in 2035. One is manufactured by the Indian company, and another one is manufactured by the Boeing. So, and all of everybody is saying that, oh, you would like to fly by the Indian aircraft manufactured by the Indian company. So this is how the scenario, that is what we are predicting in 2035. So when you talk about any devices, no doubt I'm going to talk about the medical devices soon. But you know, when you talk about the medical devices, then these valleys of death are very, very problematic, especially when the things goes from concept to engineering, engineering to entrepreneurship or companies, and then finally to the customer. You can see the concept of any product that needs to be developed, then applying engineering to it so that it will get manufactured. And once the prototype is ready and it is then sellable to the entrepreneur or company where the mass production of the product will be executed. And then finally it will reach to the customer. Now, everywhere you had to be very, very careful about the valleys or the ravine or the deep canyon. And what is important here is that if we use the technology like CAD and CAM, hopefully these valleys can be overcome to some extent. But I'm just putting the two question marks in front of the deep canyon, that means the deep valley, that how far the customer will be satisfied. That means customer satisfaction is important, and we'll have to be more careful about that customer satisfaction, or the product that is innovated should be acceptable by the customer. Okay. Now let's look at the medical devices. When you look at the medical devices, you know, when the requirement and industry, if you look at the medical devices, I'm just showing the various devices which we are using extensively in medical domain. Now the scenario is really very disturbing. The global market is reaching up to 400 billion US dollar. India's market is around 40,000 crore per year, and it is going 15% annual. And the sentence next to that is mentioning that over 80% devices are currently imported. Very, very disturbing. Very, very disturbing. 80% devices are currently imported. And therefore, you know, if that is the case, we need to rather work hard to see that these devices get manufactured. But if you look at the industrial scenario in medical devices, that is also disturbing. What is indicated here? Less than 300 Indian companies with the good manufacturing licenses are available. That is good manufacturing practices. And 90% having a turnover less than 50 crore. That means they are not very big companies in the global market. So ultimately what we look, that the medical devices, when we focus at, we are import dependent. And this particular picture is the point of concern for all of us. And that's why I mentioned the 2 points. The one is entering the market which is dominated by the imported medical devices. That means we are interested in developing the devices, medical devices, but when you enter the market, it is dominated by the imported medical devices. That's a major concern for all of us. And the another thing which I'm interested in, sorry, is the implant. which are not available on the cell. That is a customized implant. Okay, so I'm going to speak about these implants, and this implant is the one of the interesting medical device because it's a class 3 medical device, and this device is very much important. So what we should do, or rather how we should execute the research in this particular domain. Okay, so let's move to the third point. 3D printing in medical domain. Now, everyone is aware of the 3D printing, and I'm just showing you a simple self-explanatory figure here, where you can see the CAD file is now converted into the slice file, which we call as an STL format. And this STL format, or this particular is file in the STL format, is given as an input to the rapid prototyping machine, and there you can see the physical model is possible. So it's very interesting that you can actually get the CAD file created on a computer, then convert it into the STL format. That's why I have shown the two computers there. The one file changes to the STL file, and then send this to the machine. So in short, what we should say, that the physical model of whatever I see on computer as a 3D physical model, that is what exactly we will be interested in. And this particular 3D printing, everyone is talking about that, and it's not a new for even the participant also. But what is interesting for me to tell you, that this can be linked. That means this particular 3D printer can be linked to the machine which we call as a computer tomography, the CT scan. I hope all of us are aware of CT scan. Many of you must have seen it. The patients being put in the gantry, and then it is possible for you to get a CT scan of the patient. Now, this CT scan data and the rapid prototyping data, that means the working machine, RP machine. Now, this is very much analogous, very much similar. And what we have mentioned here, that the computer tomography and rapid prototyping works on the same principle. Computer tomography is against slicing. Rapid prototyping is the layer. So everyone is aware of the 3D printing layer by layer, but a CT scan, that is a computer tomography, it is all slicing. I don't know how many of you are aware of that. That once the patient goes inside the gantry of the CT scan machine, then n number of X-rays of the organ is possible to take, and then these X-rays are actually assembled, and you can see the 3D printed organ on the your CT scan image. It's like you can see the organ itself on the screen. But what is interesting is that, can we link the data of the CT scan to the rapid prototyping machine? The answer is very much yes. And this figure is again a self-explanatory figure, and you will enjoy looking at this particular figure. It's indicating that the CT scan data is passed to the RP machine, and RP machine is delivering a product which you can see there, the femur bone. It's a bone of the human being. And look at the construct of the femur bone. Just look at the geometry of the femur bone. It is very, very non-linear. It's not like our engineering product, the way we are aware of, because when I have shown you the 3D printing image or the rapid prototyping image, it is indicated that the CAD model is to be prepared first, and then you can convert that into the STL format and get the physical model. This is possible because you are aware of how to get the CAD model. But now look at this particular model of the bone or model of the human organ. There you'll find that there is a lot of non-linearity. And this particular type of the so-called product is called as a free form product. Why it is called as free form? Because if you look at the geometry of this particular product, whenever you look at the curves are not well defined. You can't define that curves in the form of an equation. There is no linearity, there is no straightness anywhere. And this type of the so-called product, or this type of the so-called the human organ, are difficult to get it in the as a CAD file. But if you can link the CT scan data to the RP machine, you can very easily see that you can get it as a physical model of the human organ. This is interesting. And this actually helps the researcher to enter into this domain of the class 3 medical devices. And because of the advancement of in the 3D printing, lot of research is executed, or a lot of research is carried out in the medical domain. So let me show you an interesting cycle. It is indicating the one of the R&D project that we have completed from 2009 to 2014, and I'm just showing it in the form of a cycle. We don't want this cycle to be completed. Why? Because we don't want the healthy individual to meet with an accident, or he should become a patient. Okay. But when he meets with an accident, or he becomes a patient, and when there is a need of rather changing or rather replacing the bone, then the methodology that is indicated here in this particular cycle is very interesting for all of you to look at. What is the first step that we do once the patient meets with an accident? And the patient, I think you can look at my cursor. So here, the very first thing is about the getting a CT scan of the patient. Once you have a CT scan with you, then that is what we commonly call as the computer data. And there are good number of softwares available in the market. One of the very famous software is Mimics. You can play with the medical image with that particular Mimics software. There are two softwares of the Mimics. One is the Mimics software itself, and another one is the 3Matic. These two software are used extensively as far as the medical imaging is concerned, and you can see, you can get the CAD data of the model which needs to be fabricated. So here I'm just showing you the CAD data. That means one of the implant that needs to be fabricated, and there, that data, CAD data, you can then send it to the rapid prototyping machine. This CAD data can be sent to the rapid prototyping machine, and ultimately you can use any manufacturing process to get a metallic implant. That's what we call a metallic implant, using this particular procedure of the physical model that is available to the rapid prototyping system. So I'm just showing here the casting route. There you can use first the casting simulation process, wherein you can fix up all the data before you actually cast, because as you are working in the field of biomedical engineering, so there are the two areas. One is the biomedical engineering, another one the aviation. In both the industries, there is no compromise for the quality. And here, when you look at this, when you use the casting simulation, it will be possible for you to set the parameters, which you can just keep it as per the data in the field. So you can get the casted part, and once it is manufactured, you can test it, and then surgeon can use that particular part that is well tested, and then finally the individual becomes healthy again. So that's how exactly the whole cycle is represented. And this is one of the interesting R&D project that we have completed from 2009 to 2014 under the title Development and Testing of Customized Joint Replacement Implant using layered manufacturing. Layered manufacturing is nothing but additive fabrication or using 3D printer. So this is how exactly the thing which is more interesting, but I will be more happy to tell you what type of the work we have actually carried out. This is a so-called bird's eye view of our project, but what exactly we have carried out in the R&D project. So let me show you one of the interesting point here. We have actually indicated how exactly the customized implants is designed. Customized, customized indicating the as per the patient's anatomy. So how do you rather get the customized implant by using the 3D printing? That is one of the major issue that we have handled in this particular project. Let me show you an interesting picture here about the hip implant, which is inserted into the patient body whenever the hip bone gets fractured. I hope you know there are all of you are aware that there are two joints which are very important. One is the knee joint and another one is the hip joint. Now both these joints actually keeps us mobile, and therefore if any one of these joint gets broken, then the only solution is to use the metallic implant in this particular joint so that the patient will become mobile. Okay. Now here I'm just showing you the interesting parameters of the hip implant or the implant which is used to rectify the hip joint. So if you see that particular implant, there are various parameters called vertical offset, horizontal offset, anterior offset, neck angle, shape of femur, etc. Okay. Now, out of these so many parameters, this neck shaft angle is very interesting for us. I hope you can see that how that particular value of the A is been indicated. And that's what exactly the neck shaft angle. Now, this neck shaft angle which is used in the implant, whether it remains the same for all the patients, that is what we have actually looked into. We have also seen how the vertical offset and horizontal offset varies from patient to patient, because that is what is more important when we talk about the customization of the implant. Okay. Now we have actually taken study of around 220 patients, and we have measured the vertical offset, and you'll find that yes, there are good number of variation, like 42 to for almost 20. And what you'll find that the most of the vertical offset is lying in the middle of that particular values, and we may conclude that yes, vertical offset do vary, but actually that variation is not much. Okay, this is actual data. That is what we have got it from the hospitals nearby. Then if you look at the horizontal offset, that's also, the pattern seems to be very much satisfying to the implant where the horizontal offset is the average of say around 50 to around 30. So that's where exactly all these vertical horizontal offsets you can think about as a parameter to be taken. But when you look at the neck shaft angle, the scenario is very much disturbing. And it's only about the 220 patients in and around Nagpur we have just gone through. When you look at the major data all over India, the thing will be still more problematic to look at. But when you look at this particular data, you'll find that the neck shaft angle varies from 140 to 124. And the variation is also not skewed at in one value, but it is very well distributed. Now, in such scenario, what is important for all of us to look at, that it is necessary that the implant is to be manufactured, which is customized. That means we'll have to first find out what is the neck shaft angle of the patient, and we need to manufacture that particular implant having that neck shaft angle. Now, on the shelf, that's what I had written also in point of concern. On the shelf, the standard implants are available, and that standardization of the implant is made based on the data that is that's known to us from the Western population. Okay. So, most of the times you'll find that the neck shaft angle is 119, then maybe available as 120, 124, sometimes 126. Now there, what you will find that the patient, say for example, having a neck shaft angle of 140, that's what we can even see from the table also. Now, when you are actually fitting the neck shaft angle, or whenever you are fitting the implant having a neck shaft angle 126 or 124, naturally it is definitely be the implant which will be loosened in due course of time. So what is important that the implant is to be developed which is customized. Can we develop that? Because see, the doctor will be always looking at us, and he will be more interested if we can give him the customized implant. And I hope now the thing is more clear to you as far as the customization is concerned. So when I look at the customized implant, you know how it will be possible for us to look at. So just look at this particular process, which is quite interesting, quite more important for all of us to look at. Now there, when you actually see the whole process of implant manufacturing using RP, then you know the CT scan data is transferred to the RP machine, and that CT scan data is actually representing the patient's anatomy. Okay, so whatever the physical model of the organ, disease organ you will get, that will be matching with the geometry of the patient. So here you can then use that physical model with any manufacturing process, and ultimately it will be possible for you to get the metallic implant. I'm just showing here in this particular figure. If you look at the last point, if you look at my cursor, you know the one which we have just shown here is a 0.5 model of the femur bone. And you know, this is what we have casted in VNIT in 2007. And that's the first success that we got it when we have shown to the medical fraternity that it is possible to get the medical implant or manufacture the metallic implant having the dimension same as that of the patient. So I hope now you can recall the way we have seen that the implant is or the patient's anatomy demands an implant of 139, and on the shelf 139 is not available. It is 124 or maybe 128, whatever it is. Now when you are actually fitting the in the patient, the implant having the neck shaft angle different than his anatomy, it will be definitely lead to some failure, maybe loosening or maybe the breaking of the implant. But with this methodology, it is possible for you to rather get the implant manufactured which befits the anatomy of the patient. And that is what we have already shown. Like we have shown that how exactly this medical model, which we get it from the RP machine, which is the exact replica of the so-called bone here, but maybe the implant that we need to fit. So you can use it as a pattern and ultimately use the casting simulations and see that it will be possible for you to get a metallic implant, okay, which is customized. Okay, so I hope this thing is quite clear to you. Let me show you some of the interesting case studies here that we have actually done in VNIT as a part of the research project, and it will be quite interesting for me to discuss along with you. So the first case study that we have executed or that we have completed is the uh, temporomandibular joint for bony ankylosis. Now, this is an interesting one. The girl, she was met with an accident, and her so-called temporomandibular joint, which is near to the ear, that gets is repaired. It gets fused also. That's what they call as the bony ankylosis, and it will be possible, or rather, it was necessary that time to develop the implant which will replace that particular TMT joint. Okay. Now let me show you an interesting figure here, and that explains everything related to the what we have done. Here you can see the patient that met with an accident is fitted with the joint made of the metal, and that is patient specific. So you can see the first two figure if you look at the my cursor. Now these are the actually the RP model of the deceased organ. So what we have actually done, that we have taken the RP model of a deceased organ and then started discussing with the doctor that how the implant is to be developed so that it can fit into the patient body. So, when I actually started discussing about the design of the joint with the doctor, so doctor used to give me some idea about how exactly the part is to be manufactured, what type of the part is to be manufactured, what will be the geometry of the part to be manufactured and all that. But then, it was difficult for me to understand that. So I told him, okay, can you just draw on a paper that what type of the joint, or rather what type of the geometry your joint will have. The doctor's handwriting is difficult for us to understand. And I'm asking doctor to get the drawing made on the paper. And, it was very difficult for me to understand his drawing. He was only indicating most of the things in air. So it was difficult for me to understand, because my ultimate aim is to see that how I can manufacture that particular implant, the design of which he will be accepting. And therefore, you can see this particular figure. This is a clay model of the implant. What I have done, I have given a clay to the doctor and said, can you just get the your shape of the implant using this particular clay? And he has done it wonderfully. This is what is the stage, the first, second, third. So around 10-15 iteration, we reach to this particular so-called shape, which actually fits into the patient body, and that is possible for us to test because our RP model was ready with us. Then we have used that particular so-called wax to get the metallic implant. That is how the whole process is. And then, once the implant is ready, based on the so-called clay model, then it is fitted into the patient body. And you can see the last figure. If you'll again look at my cursor, last figure, the lady, she was not in a position to open the mouth. But after the operation, she started opening the mouth. So for the last 6-7 years, she was not in a position to open the mouth. But with our implant fitted, it is possible for us to, for her to open the mouth. Let me tell you an interesting story here about this implant. The doctor, he got excited when he has seen that the patient is in a position to open the mouth and all that. So then doctor said that I wish to call the mm, press conference and inform to the press that I had done, or rather we have done to that this particular research work. You know, that's the first time I came to know that how to keep the so-called this press people happy, and you have to arrange a very nice so-called uh, uh, refreshment. And in the plate there was samosa, and that girl, she has not eaten the samosa for the last 6 months, 6 years, sorry, and therefore she was looking at that samosa. So doctor said whether you would like to have a bite of that, and she instantly said yes, because she was interested in eating that samosa. And when she has taken the first bite of the samosa, the satisfaction I have seen in her eyes, the that satisfaction I have never experienced in my life, whether it is the getting the promotion or getting the PhD or rather getting anything extraordinary. But this is where you'll find that the biomedical engineering research, especially with the 3D printing, is used extensively. Or rather, I should say, it is only because of the 3D printing all this thing is possible. You can see this Rapid Prototyping Journal, Volume 17, Number 5, 2011. That complete detail of is indicated in the paper, so that is the whatever the technicality you would like to go through. That also you will come to know about when you refer this particular paper. Let me tell you an interesting thing here, that this work we have done somewhere in 2007 or 9. Recently in 2021, that girl visited Nagpur and she visited doctor's clinic also. So the doctor has sent me the photograph of her where she now got married also and all that. But she actually is seen with that particular implant doing very well. So that's how the feedback is. So all this thing is that this carries a lot of importance as far as the innovation in medical devices is concerned, and when we do have 3D printing with us. Another interesting case study that I will be more happy to discuss with you is the metatarsopharyngeal joint implant. So this particular joint is fitted into the patient body in the metatarsopharyngeal region. That means you can see here, yeah, the implant that we have designed based on the data that we got it from X-ray, and then we have also studied the stress analysis of that using ANSYS, and then we have fitted into the patient body. You'll find that the patient has enjoyed a lot, because otherwise it was very painful for him to work. But when we have implanted this particular implant of what is called as a metatarsopharyngeal joint, so that particular implant is then used in the patient. And another interesting thing about this particular patient is that then he got married and he danced like anything in his marriage. And then when we have actually visited his place as a guest in the marriage, he suddenly came to near to us, near to me and my doctor, saying that it is only because of these two guys it is possible for me to dance in my marriage. So this type of the satisfaction and work together is very important. I would also like to show you one more slide that is related to the cancer patient. Here you can see the tumor that is developed on the mandible. So that one you can see here if you look at my cursor. So this is what exactly the tumor is. So what is required, that in case of a neck and hair surgery in or the cancer, the very first step is to go for surgery. And there what they do, they generally the um, uh, remove the portion that is affected by the uh, cancer cancer cell. So here if you look at this particular particular part that is being shown as a part of the RP machine, so here this bulky part is to be removed, and once you remove that, then there will not be anything in between. So the whole figure gets or the whole face get distorted. So here, what is required to be done? We have to fit an implant in place where the gap which we have generated using this particular uh, process of 3D printing. And so you can see that this 3D printed part, that is what we have designed, then it is put into the patient body, and ultimately you can see that the patient deformity, especially the face deformity, is not very much changed. Okay, so the complete picture, this paper is available in Journal of Maxillofacial Surgery, volume 71, and number 2, 2013, and you will enjoy reading this particular article, and because it actually indicates that how the 3D printing helps to the people, those who are suffering from cancer. The people in the central India, they are having a habit of chewing tobacco, and this leads to more and more cases in the of the cancer in the society. So all these things can be avoided if you have the 3D printing assisted innovation system with you. One of the interesting point which I would like to discuss with you is about the customized surgical guide for the customized implant placement. Now, the whenever you are interested in putting the implant into the area where the where you can see the implant is fitted. So that needs to be properly fitted. So here, if you look at my cursor, this is an implant which needs to be fitted in this particular gap. And this needs to be properly fitted, because if this gap is more, that will lead to more and more stresses. And finally, what happens? The implant gets looser. So all these things can be avoided if we can develop what is called as the surgical guide. That means the surgical guide will help the doctor to use the, or rather put the uh, knife in that particular region and just cut the particular part. So that is what we say about the vertical surgery, the implant that is fitted into the patient body, where the surgical guide is used. So these surgical guides are defined, or rather designed and developed again by using 3D printing. I'm going to talk about this in this startup, because one of my students, he has actually completed the PhD under the in this surgical guide, and finally he is lucky enough to get a grant of Bharat Big around 10 lakhs, and now he has started his own company where he is developing these surgical guides, and he is also importing them to many countries. Okay, so all these things is very important and very nice for us to look at, especially when we see the 3D printing being used in medical device and domain. So as I have already mentioned, the all this thing is possible because of the R&D project called Biomedical Engineering and Technology Incubation Center, which we call as the BETIC, which is a collaborative innovative project for medical device development. And this particular project, we always say that the BETIC indicates the R&D project. That means R stands for small and D is big. It's like less research but more deployed. Now, otherwise, what happens? Like most of the time, the research related to focuses only on the area which is not very easily deployable. And in that scenario, what happens? That these people from the society, they don't get an advantage of such projects. But here in the BETIC, we are only taking the devices which can be which can be put in the public domain, and is also indicating the deployment of the research. Let me show you how exactly at BETIC we do operate. So in BETIC, we have set up an ecosystem for the development of the devices, like what type of the facilities we do have, then discussion with the expert surgeon. And this is all the photographs I'm just showing you of IIT Bombay. That is what we do use it extensively. And the process, we talk about define, develop, deliver, and deploy. So these 4Ds are important. Out of that, the first one is indicating about the define process. Define process talks about the unmet need of the doctor. And that's why I mentioned there in the bracket doctor. So doctor is demanding something from the engineering community. His need needs to be properly understood. And based on his needs, we need to rather develop the prototype where all we researchers should come together. And finally, once the product is ready, that is prototype is ready in the developed state, then we can then think of rather delivering it to the entrepreneur, who will be producing it in masses, and finally it should go to the end user, that is the customer, which we call as the deployment. So here, these are the processes: define, develop, deliver, and deploy. So these are the one. This is how we actually operate in BETIC ecosystem. The various products that we have already promoted is the, as I already mentioned, that the hip joint, and then the product for the suturing, then the product flexible laparoscope and all that. So many products are ready under the BETIC. We do have regularly the medical expo every year. The people can interact with our researcher. They can actually inform them their problem, and it will be possible, as I have mentioned in the last one, that whatever the unmet needs we actually receive, we selectively get some of them, as like here, as I mentioned, 300 plus unmet needs. Then we have around 150 prototypes. Based on that, maybe 150 seems to be more interesting for all of us. And then based on that, it will be possible for us to deploy that particular prototype in the form of a product. And then that is what we call as the patent filing. So we have filed around 20 plus patent, and more than 10 medical products are ready under the BETIC project. So if you look at the BETIC project scenario, or rather the how exactly the BETIC operates. So as indicated by the yellow, so define, develop, deliver, and deploy. These are the four main processes with which we generally operate. We do get connected with the hospitals, with the industry, with the academia, and the government. Of course, all them are the stakeholders in the medical devices. And especially when we talk about the class 3 medical devices, then as I already mentioned to you, that there is a more and more research required in the class 3 devices. So there what you'll find that the interaction with the industries or hospitals or academy and government forms the part and parcel of the BETIC system. So this is how you can see how the BETIC is connected to various industries and all that. Nowadays, you know, once your R&D is over, or once you feel that your research is over, it should reflect that a certain process is, or the product is now finalized for the production. So all this thing is very important. I wish to rather show at BETIC VNIT as a form of the so-called tree. Now there, if you look at our BETIC VNIT, it is like a tree where we are attracting more and more students to work in our domain, 3D using 3D printing. And these students, they actually design and fabricate the innovative medical devices, and ultimately this will be these innovative medical devices. We do want that it should work with the startup, and the students should become the innovator. That is what we do. So you can see here how exactly the various medical devices as a startup, they are also coming. And the figure of the ladder, which is indicating the Atmanirbhar Bharat, is very important. Now, what we have written is the innovative medical devices which are manufactured in India. So there is a need of the people to rather climb our tree and pick up the innovative medical devices which are manufactured by the India, and ultimately use it in the patient. So if that will happen, then our society will become happy. So this is about our BETIC VNIT. You can see the Sun BETIC IIT Bombay help us in BETIC VNIT. But now we are changing our so-called identity from small I to big I. And that is what we have indicated in the next slide. So there when we see it as a small I, we say that it is an incubation center. But now we are changing it to capital I, and you can see that the BETIC I is capital. There we talk about the innovation side. So now, hence onward, we will be talking about the biomedical engineering technology innovation at VNIT, and what are the various activities we wish to work in this particular domain of BETIC VNIT that we are going to rather discuss in my another session also. But this is very important. I hope you have understood how we are actually working in this medical device domain. And there we are using the basic philosophy of starting everything from the doctor. So now let me take you to the conclusion of my talk, because I think more and more time, if at all we get for the discussion, that will be quite interesting. But as I already mentioned to you at the start of my lecture, I give I give more and more importance to the more and more importance to the conclusion, because there has to be some so-called takeaway message. So, what is the conclusion? Let me show you this interestingly. The I'm just showing the 3 points. The make in India for medical implants. Yes, that is important. Medical devices, because as I already mentioned to you, the more and more import dependent nature of the medical devices we have to overcome. There has to be strong academic linkages for sharing the human and material resources. This is also important, because we need to interact with each other. And as I already mentioned to you at the start of my lecture, that the uh, mm, uh, the confidence of the medical fraternity on the devices that we will be developing or designing is equally important. So that is how exactly the more that will be only possible when all of us interact. And the innovation process, which will be following the Betic model, everything should start from bed to then go, it should go to the bench and then the bed. That means here the everything should come from the doctor. What is his or her unmet needs? And based on that, we should start the research. We should develop the product. And then once the product is developed, the same product should be again available to the patient as a deployment of the research. So this is how exactly the conclusion that I wish to put it in the 3 points. But let me tell you what is the takeaway message. I hope all of you are aware of this new vaccine that is developed for the corona, and this particular vaccine the is developed by the Oxford University and in AstraZeneca. Though many vaccines are developed, but I'm find the this one quite interesting. What exactly we look at this particular vaccine, that it is the perfect amalgamation of the premium educational and research institute like Oxford and the research based company which is AstraZeneca. Okay, now both of them have worked together to develop the vaccine. Ultimately, the deployment of the research that is executed in the Oxford and ultimately the process being used by the AstraZeneca company, which is a research-based company, and it is possible to get the product in a mass scale. Now, here, when you get the product, then we look at the premium institute like Oxford, and we believe that whatever they have done is correct because we have full faith in their work. And same is the case with the AstraZeneca. That means the company which is actually fabricating, which is actually manufacturing the product. So this is a perfect methodology that we need to adopt. What we need to look at, see the way we have seen here. I have mentioned this that there is more and more confidence on the manufacturer from the developed country, the way I already looked at or rather shown to you. Now we have to overcome this. We have to say big no to this. We will be having the confidence on the manufacturer from India and not from the developed countries. So how do you rather enter into this particular domain? To enter into this domain, you know what we need to look at. We had to perfectly amalgamate the premium educational and research institute and the research-based company in India, which is rather shown by the logo of Atmanirbhar Bharat. Now let me take you one more step further. The what exactly we are supposed to do? That we need to work hard in our domain and think about how our product will be deployed, on which we will be researching. So now, many times the people, they say that, oh, premium education institute, mine is not a very premium educational. I'm not the person who is here. There are no facility, this and that and all that. Stop doing that. What is important, that you may say that, okay, I do have this much of limited facilities or the resources available. And based on that, I will take the very first baby step about development of the product. Now, once you start looking at the problem, or rather once your product demands more and more resources, you need to collaborate with other educational institutes also, or the researcher in other educational institute also, and see that you get coupled with them. That is what exactly the perfect methodology. And if you start in going from one baby step to the next baby step, like that, you'll come to know that you together have developed a very nice product, which will be appreciated by the so-called premium educational institutes in India, or the research institutes in India, where we talk about the ISC, IIT, or the CSR labs. You'll find that they themselves will get excited with your research, because with the limited resources available, if you can show them that how the product can be deployed and what are the problems associated because of the less resources available with you, you will find them entering into your domain. This is what exactly the methodology will be. What happens is that many times the people, they approach to the higher education institute of repute simply with an idea, but showing nothing as their contribution. And that contribution has to be in the form of an hardware. So what is important here is that once you show them that with the limited resources, if we can uh, deploy your research to a level, and then finally you can then approach to the education institute of repute, then definitely they will start helping you. They will like to rather involved in your project. And see, that is how you will have to progress one step after the other. And then finally, once your product is ready on a paper with the deployment and all that, then you can then approach to any research based company which can uh, help you in getting your product manufactured in masses. So all this thing is required. It's a takeaway message here, that all of us has to work hard in this particular direction. And simply calling bad names to the our institute and simply saying that this is not possible here and there, if this attitude is continued, then we will be always dependent on the imported devices in medical domain, and it will be difficult for us to rather uh, give the healthcare services to the people from India. And once your product is ready, then any research-based company will be ready to take your product for the mass production. So this is a takeaway message for the class 3 medical devices that we will be now interested in. Use of the 3D, it is only because of the 3D printing usage, it is possible for us to rather develop the product. And that is what I told you about, the customized product, tailor-made product in medical domain. So all this thing is very important. So I think time is almost more than an hour and 50 minutes. So I wish to thank you all. My email ID is amkemi2002@yahoo.com, and I'm open for the discussion. Thank you. Yeah. Gajendra, Radhesham, I'm open for the discussion. Okay. So we'll be more happy if you can discuss your any queries related to this. Okay. So can I just
Hello, participants. If you have any query, you can ask.
I will stop sharing here. Yeah.
Hello,
I'll be happy
participants.
to any question, anything
So,
which you feel that it may be even not very much concerned with whatever we have discussed, but you wish to ask me, even for that also I'm ready. Because if, ultimately with the more and more interactions, we will be learning a lot rather than simply nowadays everything is available on the net, and we get once you start getting an information through the net, we are ourselves will find very much fatigue, and finally we say okay, enough of knowledge, no need to go into the detail. But this will never help unless you do something, and that's what I told you. That is a takeaway message. I would again like to repeat it, that if we can show something at your end, maybe in the form of a hardware, to the person, to the faculty members from the institute of repute like IIT or ISC, they will be really happy to see that, and they will feel that, oh, you have done a wonderful work. So, and then they will start interacting with you, and this type of the baby steps are always required. Okay, yeah, I'm open for that.
hello,
Yes. uh, Maybe I think
hello, participants. Please, any query?
if there is anything on the chat, let me see. Okay. So, doesn't matter.
Sir, I'm
Yes.
Robin from CCET, Bhilai.
Yes.
I'm doing my
Okay.
MTech. Sir, my query is, it's not related to any, my query is about an opportunity to visit your center.
Oh,
Will we get any opportunity?
yes, great, great. I'm really happy. And I think it's my standing invitation, not only to you, but all the participants, that please do come and see our facilities at VNIT. And that's what I always used to say, that I like that particular advertisement of Ghadi detergent Tikia, where they say that pehle istemal karo, fir vishwas karo. Exactly in the same way, please do come, see what we are doing. And I'm going to rather show you in one of in my another presentation, that how we have now entered into the domain of tissue engineering, and how exactly it is helping us to enter into the domain of the startup. And that's what is very important nowadays. So we are now interested in developing an ecosystem in the central India, where we can actually help more and more people to start their own company. And it is not only to help them in just pushing them in the startup and saying that okay, now you handle your company on your own, but we are now thinking of nurturing them systematically with the guidance and all that, so that whatever the research we have carried out, or whatever the research the researcher has carried out, all these things should be deployed. And ultimately, you know that's what I'm going to say in the next session also. But the people, there is a every time they say that the be the job creator and not the job seeker. Now this phrase itself, not the job seeker, job seekers will be always there. And if there are no job seekers, then how the job creator will work? It has to be only be the job creator. So how we are going to create the jobs? By using our research, that will be of more interest to us in our next phase of development in the CARICAM Center. And under the basic VNIT, that's what I told you, Biomedical Engineering and Technology Innovations. That is what I told you, a small I changed to capital I. There we will be now interested in developing this particular ecosystem. What are the various ways by which we will be handling that? That is all I'm going to discuss. But if you visit our place, then that will be quite interesting for us to interact with you, show you what are our plans. And now background, you can see our CAD/CAM center, but that's only one story. Now we have built another story on that, and it is that particular construction will be over within 1 month or so. And later on, we will be operating our Betic VNIT center from the second floor. So that will be quite interesting, where we will be more interacting with the people, researchers, especially the postgraduate students, the PhD students, and what we are intending that they should enter the technical field with their research that they have carried out. You know, though I think it is too early for me to speak about that, because unless we find ourselves successful in that, the most of the students, those who actually complete their PhD, I have found their work very promising. But ultimately, what happens that once their PhD is over, then they go on searching the jobs. There, what will happen that the most of the cases, they work in the institute or the industry where their research is hardly used. Such things should be avoided. We call this as an underemployment. Now, this underemployment should stop. So all these things, how it will be possible for us to look at, then I will show you also that what are our plans in the Betic VNIT. So all these things will be quite interesting for me to interact with you, we discuss with you. So do come, Robin, please do come and just to give me the call or just write an email to me. It will be quite interesting for me to interact with you. Only for, I think you should wait for a month or so, because our Betic variety sale is also yet to be completed. And let this pandemic be totally over. At least you should feel yourself comfortable when you will visit our center. So yes, Robin, you are welcome. And please do write to me. My email ID is with Radhesham Gadgar. Even my mobile number is also with him. So you can take all the details about me from him and then do visit us. I will be quite happy to interact with you. Actually, I'm waiting for you to visit our center. Yes.
Thank you, sir. I'm excited.
Oh, great, great.
Yeah,
Great.
any other participants? Do you want to ask anything? Do you have any
Good evening,
query?
sir.
Yes, yes.
Sir, this is Dr. Kumbalkar. Sir, actually, I'm from the Nagpur, and
Okay.
yeah, and right now I'm working in Pune. So I have done somewhat analysis over the knee joint. Yes, and my some papers are also published in Springer. But sir, I have one query about that analysis over the knee joint. That so, how can we go with for the force analysis while considering the muscles in the knee joint? Because I have
See,
considered that femur, tibia, and patella, and finding out that somewhat stress analysis over the patella also. But I just observe some difficulty while considering the muscles.
it's difficult to rather interact on this platform with the technical aspect of your work, because I'll have to first go through your work and see what exactly
Okay.
you have done.
Yes.
But what I'm interested in that if you have carried out your analysis,
Yeah.
whatever it is, because I have not gone through your work,
Yeah. Yes.
but my simple question to you that
Yes.
whatever the work you have carried out, are you discussing this with any medical doctor? Are you in tune, or are you continuously interacting with him with your research work? Are you doing that? Yes, Kumalka,
Medical
are you
officer.
interacting? Interacting with any
Yes.
doctors about the
Yes.
work that you have done?
Yeah, yes, sir, yes. I have interacted, and they have also shared me some case studies among which they have operated over the
Okay.
number of. Yeah.
Okay. Now, what? Now, let me. I'm happy that you are interacting with the medical fraternity or the surgeon.
Yeah.
Now, you know, this study will go on. There is no end to it.
Yes.
Because this is a very complex so-called the domain,
Yes.
because it is an interdisciplinary domain, and we as an engineer
Yeah.
interacting, rather dealing with the living cells or the living organs, which
Yes.
is not actually, frankly speaking, our food.
Yeah.
We are always working with the metals and all that as an engineer. And
Mhm.
when you actually enter into this domain, so this work, there is no end. And
Yes.
there will be always some issues. And many times I have seen, it's my own experience,
Yeah.
that when we actually work with a particular doctor or medical fraternity, the other medical fraternity or other doctor may not like that particular work. And then he said, no, no, this is not possible and all that. And we get frustrated because we
Yeah.
are always thinking as if whatever work we are doing, it should be accepted by the all people in the medical sciences. And that never
Yes.
happens. So in
Mhm.
that scenario, what I feel, that whatever the work you are executing,
Yes.
as I have said to you that I have not gone through your work,
Yeah.
the very simple thing or very simple question you should ask yourself, like, what is the deployment of your
Yeah.
work? That means how these people in this society are
Mhm.
getting the help from your work. If you
Mhm.
answer this question, now
Yes.
look at it. Say I have shown you our case study, the implant that we have developed and fitted into the patient body. You have already
Mhm.
seen my presentation.
Yes.
Now,
Yes.
that time there was a need of developing the implant, and that
Mhm.
too a customized one. That means fitting to based on the patient's anatomy. Now,
Mhm.
there we have designed, developed, and then we analyze that implant also. And that's why if you go through the paper that we have published, there you can
Yes.
see even the stress analysis and everything that we have carried out. But the very first thing that I would like to tell you, our goal was fixed. That
Mhm.
the goal is to design and develop the implant, or rather the joint, for that particular
Mhm.
patient. I think
Yes.
that has to be there. Otherwise,
Yeah.
what will happen, Kumalgar? You go
Yes.
on discussing about this from a different angle, and
Mhm.
finally, what is the deliverable? What is the deployment of your
Mhm.
research? If it is not sure,
Yeah.
if it is only for getting more and more paper publication, I think
Mhm.
it's okay, because
Mhm.
that is also valued in our academic field. But unless
Mhm.
it comes out with some deployment or
Yes.
other the patent, then
Mhm.
only then it will work fine.
Yes.
So
Yes.
your work will be valued. And uh, if you do this, if you adopt this methodology, if you go through this approach, then
Yes.
even the medical fraternity will be also interested in your work.
Yeah.
And
Definitely,
they'll
sir.
say, oh, this fellow Dr. Kumbalkar has given us a nice product by which
Mhm.
it will be possible for us to rather operate the patient very easily.
Yes.
The whatever the study you are doing, about the force analysis, stress analysis, and all that, based on that you have developed the software, and then you are giving it to the doctor, saying that use this software while operating the patient. You will come to know that where exactly the more stress is coming when you use the implant. I think this
Mhm.
type of the methodology should be there. Otherwise,
Yes.
simply working on a system,
Mhm.
that too a biological system, which is very complex. And
Yes. Yes.
we feel sometimes fatigue. We feel that, oh, how much work I had to do and all that. I don't know if at all if you are guiding any student, or if this is considered to be MTech project or the PhD project, then that student will always look at it, oh, when I'm going to get my PhD or MTech, and then I forget everything whatever I had done. I think that should
Yes.
not happen. That should not
Yeah.
happen. I
Yeah.
don't know how
Yes.
far I have satisfied you
Yeah.
with your answer,
Yeah.
but unless
No.
I see your work, it is really very difficult for
Yes,
me.
yes, yes, yes. Thank you very much.
Please,
Sir,
please.
actually, I have referred you so many papers also. So
Okay, okay.
I
Please,
just
please,
asked.
please send me the details if you wish. And as I have requested Robin also to visit our place, so please do visit You say that you are from Nagpur only, so there is no issue. Anytime you just come to our CAD/CAM center, and it will be quite interesting for me to discuss with you. Okay.
Yeah, thank you very much, sir. Thank you.
Yeah, sure. Yeah.
Okay.
Yeah.
Any other query?
Uh, I'm really happy that the people are quite interested in this particular interdisciplinary science. Uh, you know, I always used to say that we need more and more people to work in this interdisciplinary field. What I have seen, maybe you all will agree to that. In most of the educational institute, we work in a very watertight domain compartment. I've sometimes seen in many engineering institutes in the board of studies meeting or the senate meeting, the people are fighting that he's from production and not from the design and the thermal and all that. Even in mechanical engineering also, we work in a watertight domain. We say that, oh, I am from thermal. No one should enter into my domain if at all he is not from thermal and all that. There was a lot of fights going on in many universities about the production and the management, production and industrial engineering, materials engineering, and the mechanical and all that. I think this should be stopped, because ultimately, when you look at the discipline like biomedical engineering, there it is a highly interactive, highly interdisciplinary, and there more and more people should enter. And many times I have myself has faced the problem that whenever I used to discuss anything related to the research that we have carried out, immediately many times I get the question from the uh, people, those who are interviewing me or those who are actually judging our research. Have you done your biomedical engineering graduation from any university? I said, no, I am mechanical engineer. I think most of you people must be aware the University of Harvard, and that is an MIT and Harvard, is very famous. It's because it's number one in the world for the last so many years. There, when I visited in 2011 and delivered a talk there, I have seen the audience, many people, those who have actually completed their bachelor's degree in arts, and now they have entered into the engineering field. Many people have seen that they have completed the civil engineering and entered as a dentist. All this thing is possible there. Anyone can enter in any discipline. I think the new education policy is getting framed in that direction. But what is important here is to see that, okay, that is in Harvard, I have seen like the physics student is now professor in mechanical engineering department and all that. But not to that extent, but at least mechanical engineering and the materials engineering, or maybe the biology student and all that, all of them should work together, because ultimate aim is to see that we are serving the society. So society should get benefit of the research that we have carried out. And ultimately, if the more and more research papers are getting published, and common people are not in a position to get any benefit out of that, it's really very difficult for us to digest. Let me tell you an interesting thing. One of the universities in USA, what they generally do, that once your PhD work is over, then in most of the universities we do say that it is the PhD pre-submission seminar and all that. That's what we actually conduct, and we invite the faculty members from the department and all that. There they say that if at all your PhD work is over, then present this particular work in front of the common man, who is not a technical person, if at all you are from engineering. If you are from the arts, who is not expert in the arts. So with the common man, they may say that even to a canteen fellow who is not even aware of what exactly the engineering, and just tell him what is your research work. And they would like to see his opinion or her opinion about that, like what he thinks about the work that you have done. If their remark is satisfactory, say, yes, it seems that my life will be different once you actually produce this research, or once you deploy this research. I think that is what should be the spirit. If this spirit is maintained, naturally everybody in the society will look at us with the pride, saying that yes, he is the person who is going to rather upgrade my life, or my life will be smooth, comfortable because of his work. So all these things should come in the society, or rather in our so-called technical society, and especially those who are interested in research. So I think that will be quite interesting. Yeah. So
Thank you, sir. Thank you very much for sparing your precious time and sharing your knowledge and experience with us. Your session was very interesting, sir. You shared your so many live examples, and your work is very excellent in the medical field, and you are trying to develop different implants to make the uh, people of life very comfortable, and also you are doing very good work in the medical field along with the medical professionals. So I think there is need to work, we have to work together
yes,
along with the doctors, engineers, other engineers of other faculty also,
yeah,
so,
yeah, yeah,
so that we can give the comfortable life to the common people.
yes,
So
yes.
I
It is
think
very much required.
uh, this session will be very beneficial for all the participants. They will learn a lot of things, and also they will get motivated to do the work, research work in this field. So thank you very much, sir. Also, I would like to thanks all the participants for joining and attending the whole session with lot of patience. So thank
Yeah,
you all.
it was a
Thank you.
long session, rather. I think 1 hour and 40 minutes more, almost quarter to 2 hours. But it's interesting. Please
Yeah.
ask them to write to me anything, whatever they feel like. Okay.
Yeah, sir. Sure, sure. Thank you. Thank you very much, sir.
Thank you. So can I leave the system now?
Yeah, sir.
Okay. Thank you. Thank you.